Welcome to Fluid Mechanics Lab 1. My name is Dan. If you have any questions about Lab 1, you can contact me with this email address. That is student.unimed.edu.au. And also you can contact Hamai, who is another lab demonstrator, with this email address. In Lab 1, there are two components. The first is that you need to measure pressure drop at different flow rates. And the second part is that I need to demonstrate the dye injection so that you can observe the transition from laminar to turbulent flow. Okay, so let me give you a little bit the theory. Since we are dealing with the straight horizontal pipe, and we can apply Bernoulli equation. So straight in horizontal pipe, so we can say its height is the same. And also we are dealing with the same cross section at here, and the mass flow rate is the same. So the velocity at point 1 here and point 2 should be same. So we can say velocity 1 equal to velocity 2. So with this, we can say this term is gone, and also we can get rid of this velocity here. And we have the pressure term on your left hand side, and on your right hand side you have a pressure term and head loss. So we can rearrange this equation for head loss. So with this, we can say head loss is delta P over rho G. Also, we can express the head loss in terms of the friction factor and length and diameter and velocity. So they are the same, the head loss. So we have one equation here and the second equation here, and the head loss are the same. So you can say equation 1 equal to equation 2. So let's replace this head loss with the delta P over rho G, and you can place this term on your left hand side. So delta P over rho G equal to 2 times F L over D V square over G. And we can cancel G. And since we need to find this friction factor, and we can rearrange one more time. So we can get the friction factor is delta P over rho, and this D go to here, and 2 times L V square. So you can get the friction factor with this equation. So once you find the friction factor, and you need to plot the friction vector versus the Reynolds number, that's the major part of your the calculation in your report. Okay, let's move on to the experiment. Here is the schematic diagram of the experimental setup. As you can see that we have 3 rotometers here, and which have 3 different scales. The first one 1600 liter per hour, and second 250, the last one 70 liter per hour. And with these rotometers, you are going to measure the pressure drops between 2 points, and the distance is 1.5 meter. And you are going to use 3 different pressure gauges. The first, digital pressure gauge, and second, inverted water-air manometer, and also you are going to use capsular pressure gauge. It doesn't matter which one you start first, but for example, if we want to start 1600 liter per hour, you change 12 to 16 different flow rate, and you are going to measure corresponding to pressure drop with the digital pressure gauge. And for the 250 liter per hour, you do the same thing, but you have to obtain at least 10 different flow rate and measure the pressure drop with inverted the water and air manometers. The less the small flow rate, so you are going to obtain the 7 to 8 different flow rates and measure pressure drop with capsular pressure gauge. Okay? And after finish all the pressure measurement, I'm going to demonstrate the dye injection. Okay, in your report, you need to include abstract, and you need to include the aim, and you need to answer all the questions, and also you need to show all the calculation so that I can see how you get the answers. Okay, and also you need to include conclusion and appendix as well. The safety is top priority in this lab, so you have to wear safety glasses during the entire experiment. And also you need to wear long sleeve shirts, and also you need to wear closed-toed footwear as well. And before you leave, make sure that you check the attendance with me, and also get your cover sheet signed. Okay, and also you need to include your cover sheet in your appendix as well. Okay. Okay, so this is the experiment setup. As I explained, we have three dosimeters here to control inlet flow rate, and we are going to use three different devices to measure pressure drops. Here we have digital manometer and inverted water and air manometer here, and capsulating the pressure gauge here. Okay, so before you start, you need to make sure that the pressure reading is 0 in digital manometer, and also make sure that the water column in these manometers are same, and also the readings is 0 in capillary pressure. And once you confirm that, and you can start your measurement. And so let's start with 1600 liter per hour, the rotometers here. And the second one is 250 liter per hour. The last one is 70 liter per hour. So, as I said, if you want to use 1600 liter per hour the rotometers, and you are going to use digital manometer to measure pressure drops. So before you turn on these rotometers, you come to this side, and you need to open the valve for digital manometers. So there are many lines here, and it looks complicated, but it's not. So the tubes are connected to each upstream and downstream, and you need to make sure that you open the valve for the right devices. So for example, we are going to use a digital manometer. So first, you need to pick this tube and make sure you follow the tube, and then open the digital pressure gauge here. And you pick the other one and follow the tube, and you need to open digital pressure gauge here. So now it's ready to measure pressure drops between this upstream and downstream. So here's a P1 and here's a P2. And the distance is 1.5 meter. Okay? So make sure that only valves for this the manometers are open, and the other ones are closed. And once you confirm that, you come to this side and open the valve and change the flow rate 12 to 16, the difference. So let me start with now it's reading is 400 liter per hour, and you come to this side and you read the pressure drop. So now it indicates 2.1 kilopascal. So there's a pressure difference between P1 and P2. Okay? And you come to this side and you change the flow rate of 12 to 16, and you will get 12 to 16 different pressure drops. Okay? And once you finish, you close the valve and come to this side and close valve for the pressure gauge. So close in upstream and close the valve in the downstream. Okay? Now we need to use the inverted water and air manometers. And as we did before, we need to open the valve mainly for manometer here. So as you can see, there are two tubes connect to this valve. And the first one is here, the manometer in upstream. Open it, and you follow this tube and open the valve here. Okay? And make sure that the other valves are closed. And now we are ready to use this inverted water and air manometers. And you come to this side, and as we did before, you are going to change the flow rate, and you need to obtain at least 10 to 12 the different flow rate, and you are going to obtain 10 to 12 different height. So for example, if I start $50, and I come this side, and I need to read how much heights are different. Okay? And you come to this side again, and change the flow rate, and go to the manometer, and then check the height, and do the same thing until you obtain enough data. Okay? Once you finish, close the valve, come to this side, close the valve for these manometers. Okay, now it's time to use capsullated pressure gauge. So before you do that, you need to make sure that you open the valve for capsullated pressure gauge. So you follow this line and make sure that this valve is open, and go to this line and then make sure that this valve is open, and make sure that the other valves are closed. Okay, and you come to this side and you open this valve, and then you can measure 7 to 8 different flow rate and measure the different pressure rate with the pressure gauge. So for example, here now it's 10 liter per hour, and you come this side and wait about 3 to 5 minutes, and then read the pressure readings in capsullated pressure gauge. Okay, and do the same thing with a different flow rate, and you obtain the corresponding pressure drops. Okay, and once you finish, close the valve and come to this side, and make sure you close the valve in upstream and downstream as well. Okay. Okay, so now let me demonstrate the dye injection. Okay, here's the dye. It's coming through this tube, and the dye coming from this side to the other side. Okay, so what I'm going to do is I'm going to change the flow rate with the the rotometers. So I start with the 20 and 40, and then I close this valve and then open 250 liter per hour the rotometers. So I start with 100 and 200. And then I close it, and then I come to 1600 liter per hour and open 800 and 1200. Okay, I'll come to this side and have a look at this inlet.